All right, everybody, I hope you can hear us. We had some technical difficulties. I can't even say the word technical difficulties. Hey, I'm here. I'm with my friend. Oh, I'm pointing the wrong way. Let me point the other way. I'm pointing right at you here, Rob. Rob Sutter, say hi.
Hi, everybody. It's Rob. Oh, I'm pointing the wrong way too. Eric's over
Yeah,
there.
we're learning here on this. Hey, so we haven't streamed in a while, so we're obviously out of practice. Eric broke everything. Rob was ready. Eric broke everything. So there it is. So excited you're here. Welcome back to Sessions with Sam. Today, what are we covering, Rob?
Today, we are covering the recently announced support for AWS Step Functions.
Yeah.
AWS SAM. One of my favorite services. This is a huge deal, y'all. So we're going to go through, serverless for everyone.
That's right.
So we're going to go through what that looks like and how you can go off and build. And then I'm going to throw some code over the fence to you. And then you can go build. How about that?
Yeah. So the way we're going to do this is we're going to kind of show you an example. Rob, I don't think we're going to get through everything today, right? But we have a full app to push up to the repo, to the Sessions with Sam repo, which I'm going to actually just throw the links in here real quick. And you should see that it's listed there. And then they should be able to play around with it, right?
Bang, links. That's right.
Yeah.
Now, full app, except we didn't implement the your own business rules, right? So it's up to you to do that last mile based on what you need. But it's the framework,
That's right. But this shows how to do it in step functions. So, all right. Well, are you ready to show some code?
I am ready to show some code, but maybe there's some people watching that don't know what step functions are.
Oh, hey, that's a good idea. So yeah, why don't you take a minute and explain step functions?
All right, I will. And
real quick, I'm going to throw in, hey, I asked you to talk now. I'm going to talk, so I apologize. Real quick, I'm going to say, we say step functions, but you're also going to see state machines. And Rob, you can kind of explain why that is, but those are synonymous, yes?
Yes.
Okay.
And in fact, if y'all will bear with us just a second, we may have to do some more switchy because it looks to me like it's sharing the wrong screen on the stream, but whatever.
That's all right. We'll fix it. Hey, I see it.
Somehow Eric's spine. Yeah, that's better. See,
we're good.
You weren't supposed to see the magic code behind the.
Oh man, that's how we make the sausage,
Pay no attention
folks.
to that man back there.
That's right.
So, like Eric said, right? So AWS Step Functions is the name of the service, right? And inside there, just like you have AWS Lambda, and then the unit of thing is a function. Inside AWS Step Functions, your unit of thing is a state machine or a workflow.
That's right.
State machine, if you're familiar with finite state machines, that's exactly what it is. It's a computing structure that can only be in one predefined state at any given time and moves through these states in a determined order. Or if you're coming more from the business side of the house, you can think of it as a workflow or even a business process, right? So it's these things together, including the visualization. And what it does is it helps you orchestrate all the different steps, choices, and outcomes that you have in that business process to achieve your desired result, right?
That's right.
So,
one of the things I tell, when we look at code, a lot of times we see people orchestrating in code. A lot of if-thens, a lot of switches, a lot of stuff like that. And we want to get away from that.
Yeah, absolutely. Step functions is a solved problem solver for you, right? If you need to do retries with exponential backoff built in, if you need to catch errors and do things based on whether you got a success result or an error state, different classes of errors built in. If you need like management of state throughout stateless invocations of Lambda functions built in. So anytime you're doing some sort of anything in your code that's not pure business logic, you need to be asking yourself if you can lift that out into a workflow or a state machine.
That's right. Uh-oh.
So.
What? You went quiet for a minute there. We got you now, though. Yeah, it seemed quiet.
Yeah,
okay, we're good, though. All right, you ready to show some code?
Yeah, let's do it. It's unusual.
All right, let's do it.
You know something went wrong if I'm quiet because
I am that's true. Quiet. Yeah, I can attest to that.
Some code. There's a couple different ways we can get at this. So we're going to be using AWS SAM CLI, the AWS Toolkit for Visual Studio Code, which also has outstanding built-in support for step functions. What I'm going to show you here is the CLI, just in case you're not using AWS Toolkit for Visual Studio Code, right? But I'll show you as well. So one thing that we notice here, we do SAM init, our classic way to get started, and we're going to use a quick start template. I prefer to write my functions in Go. You do whatever works for you. We're not actually going to write any Lambda functions at this stage. Let's just call it step functions.
I'm a Node guy myself, just throwing that out there.
Node's great. Python's great. .NET's great. Java's great. Whatever helps you get your task done, it's great. But
That's
what
right.
I want to point out here is this second option now that we didn't used to have in SAM init, the step function sample app for stock trader. So we're going to use this to sort of see what all gets built for us. So now we've got this app that's been built. I can get rid of this little guy here. And we've got this full template, but we've also got this state machine folder with our state machine defined in it. State machines are defined in what's called ASL, the Amazon state language. This now can be rendered here inside Visual Studio Code. So we know that our stock trade machine does this process, checks the value. If it meets a predetermined threshold, you sell it, or if it's below a predetermined threshold, you buy it, and then you record it to DynamoDB.
Where did you get that graph?
This graph?
Yeah.
Do I have my little preview? Oh, my preview's not on. Where's my, hold on.
No, I can see it. Yeah, I want to know where you got that graph that's showing up.
Right here. There's a couple different ways you can do it. One, there's this, just to the right here, there's this little icon that looks like a workflow. If you click on that, boop.
And that's part of the AWS toolkit, right?
That is part of AWS Step Function support in the AWS toolkit for Visual Studio Code.
That is slick. That is really cool. All right, sorry for interrupting. Go ahead.
It's almost like I've said that once or twice before. And in fact, I'm going to hit this little bang links over here.
Yeah, I was going to say shameless plug time. Yeah.
Yeah, shameless plug time. I did a whole series on AWS Step Functions here on Twitch, and it's available, both the code, there's a link to the code when you hit bang GitHub here, and then there's a link to the video series that we just put in the chat for y'all. So make sure you check that out if you want to learn a lot more about the capabilities of step functions.
That's right.
There's another, we could also do this render graph right here. If you see my mouse, we click render graph and it does the same thing. And then, like always, you've got the command palette where you can render state machine graph. You know, we like to give you a lot of ways to do things so that you work your way.
That's slick, dude.
But, so this is a state machine, and this is like a relatively complex one. Right. So let's back out of this. I just wanted you to see what we give you when you run SAM init and use that quick start. So that's a fully defined state machine here in this asl.json file. And we've given you 3 Lambda functions. But here's where the magic is happening right now, is in this AWS serverless state machine transform. And y'all might not know this about me, but I am an avid fan of the Sessions with Sam series. So I've watched Eric, so I know he knows what I'm about to say.
That's right.
But just like there's an AWS serverless function transform and an AWS serverless simple table transform and API, REST API, HTTP API transforms, this is what's new here. Previously, you had to do this with, it would look like type AWS step functions state machine. Right? And just like when you define a Lambda function in vanilla cloud formation, when you do this with step functions, there's like a lot of options, and you have to define that JSON that I just showed you in line. But when you use this serverless transform that you get with SAM, you can just refer out to that template and then pass in substitutions here. So when we go to this template, we'll find a string substitution template for stock checker function ARM. And then we inject this actual function that we've defined right here, the ARM property of it, right? So much more modular, much more composable, much easier to look at and understand. And at the same time, you still get those visualization capabilities from the toolkit in Visual Studio Code that you didn't have before. So if I open that back up and we're looking for stock checker, ta-da, this is what it looks like, right? So it's using that $ brace substitution to inject your AR in, but at the same time, we still get the visualization. So how cool is that?
That's super cool. Hey, Rob, can you use YAML in the ASL?
So what day is today?
Today is
the 18th of June.
Yeah.
No, you cannot write your state machines in YAML.
Okay. All right.
As of the 18th of June.
That was awkward.
right? And I am an awkward guy. But it's weird because you can write your definition string in line like
Right, right.
this, and then it looks like YAML inside your CloudFormation template. So you provide either the definition URI. It may actually be definition now. Y'all want to go doc hunting with me? Let's go
Let's
doc
do it.
hunting. Let's see what we find.
Let's do it. So the idea here is, while Rob hunts, I'll explain. So what we're looking like, yeah, no. So what we're talking about here is when you define it. If you've done API Gateway in SAM, it's the same thing. I can declare my API Gateway right there in the SAM template, or I can call an Open API or a Swagger template. So it's the same thing with the ASL template. I can define it right in the body, or I can pull out and I can pull in an exported file. And when they get large and crazy, I suggest using external files like this sets up. But when it's really quick and small, inline is very helpful.
Yeah.
Definition it is.
So this is what, yeah. Eleanor, I appreciate the comment, but I was hinting the other way towards what I'm showing you right now. We don't like to call this supporting YAML. But if you look at this, it's defined in YAML, right? So I was more trying to talk around, I can't call this YAML, even though it is.
Yeah.
Right?
Yeah.
So you can define, and this is a complete state machine. This is a complete SAM template that you're looking at here that defines a single state machine and can put some metrics, right? So just like Eric said, if you're doing something simple, you can define it inline, and it is definition, not definition string. Definition string is from the old one. And you just define your states in line. Now, just as Eric said, the preferred technique is, as they get more complex in real world, is to pull them out into their own file, because you also gain the visualization characteristics. You can take it to your analyst and say, is this what you think this does? And you can agree visually until you get it right, which is pretty powerful, right?
Yes. I think it's awesome. Yes. I'm really jazzed about this. I'm not the step functions expert that Mr. Rob Sutter is, but I am a SAM fan, obviously, if you followed along in anything.
Loves that guy.
Yeah, I love SAM. I have the squirrel outfit somewhere. I might go put it on. I get so excited. So
please no.
Yeah, okay, well, all right.
Not today.
Okay.
Because we have limited time.
We do. We have limited time. All right, so what did you build for us?
Well, I want to show you two more things, because there's two really big things that SAM support gives you, right? And they're both right here on the screen. One is events. And as you can hook up your Lambda functions to fire based on API gateway input, based on a schedule that you specify, based on messages coming into a queue, you can do all those same things here for your step functions workflow. So you gain access to all those events. You can put an express workflow behind an HTTP API, and then you get that asynchronous initiation and that rapid response, right? So you get a really reactive application for your users. They immediately know that workflow has been kicked off. Meanwhile, behind the scenes, all these other things are happening. So it's really easy to wire up this way in SAM, just by using this events stanza or configuration that you get here. So I think that's pretty cool.
It is. Step functions becomes a it always has been, but even more so with the support in SAM, it becomes a huge viable resource in the serverless ecosystem. I mean, just, hey, I'm going to trigger a Lambda. Hey, you know what? I need to orchestrate some stuff. I'm going to trigger several Lambdas through, or direct integrations, dare I say, right through step functions. Now, real quick, and I know we're short on time, but talk a little bit about synchronous and asynchronous in this.
Yeah, so there's three ways that you can invoke a step functions workflow. One is what we call request response. And that's just kick it off. It's enough for me to know that it's started, and I trust the workflow to handle everything else, right? And then you also have these patterns across all service integrations, and they behave differently with the different services. The other is run a job, or the .sync invocation. And what that does is, hey, block, invoke synchronously, stop everything else, go out, do this, and then when I'm done, take that response object and proceed with the next step. And the third is wait for a response, or an asynchronous invocation, where when you invoke things this way, Step Functions creates a task token for you that's available in the context object. It's just like a little GUID. You can think of it that way. And you pass that into your task. That task can be a Lambda function, a Fargate task, something running on premises, however you can get something somewhere. But then it halts execution and waits for a callback. And then once you call back with that token, it proceeds. And this is where in a standard workflow, you can pause that execution for up to a year. So you can insert human involvement here. You can say, hey, look, you need to escalate this to the VP. Well, the VP's on vacation for 2 weeks, and then after that, she's really busy, and this may take several months. That's okay, because your execution can wait for up to a year on a standard workflow for that to complete. So those are the 3 ways that you can invoke. Okay. And then you use them differently depending on what your use case is.
All right, very cool. Thank you. Back to code.
Back to code. Okay, so the second thing that I think is incredible now is this. These AWS SAM policy templates that, again, I know you've covered before, but previously when you created a Step Functions workflow in CloudFormation, you had to also create a role and attach that role to the state machine that you defined, or to the workflow that you defined. Now you gain access to all of these predefined AWS SAM policy templates like DynamoDB write policy, DynamoDB read policy. You see here the Lambda invoke policy. There's all sorts of predefined. I forget what the number is. Do you know off the top of your head?
No, but I'm getting ready to paste the link to it because there are a ton of them. So if you want to take a look here, this is the GitHub repo. We have them listed. I think there's roughly, I'm going to check real quick. But you go ahead. I'll get a count on them.
Yeah. While you're doing that, there's an issue in that repo with a PR submitted by a fine AWS employee to add support for synchronous invocations. Everybody should go +1 that issue right now so that it gets floated up to the top and imported, because it's just a new stanza that you can get. So +1 that PR. Eric will find the link for us.
Yeah, I'm getting it right now.
But this is huge right here. The ability to just use, there's stuff defined for SageMaker. There's stuff defined for SNS to put messages onto a topic. So all of those now, much, much simpler. Everything's referential instead of being hard-coded. Beautiful, beautiful stuff. So that's the 3 biggest things that I like about this release of step function support inside SAM, right? This predefined template that really gives you a best practice for getting started, the ability to wire up those events so easily, and the ability to apply those SAM policy templates as you're building your state machines to really scope and restrict your permissions to only exactly what you need to accomplish those tasks. Really, really reduces your attack surface. So before I talk about what we pushed up, because we're not going to have a whole lot of time to build on that, I want people to see that certain things remain the same, right? SAM build remains the same. It's just going to package up our functions, get any dependencies we need, in this case, compile them because it's Go. First, I need to change into the directory. That always helps. And then SAM deploy, using the guided deploy, still the same. We'll do this real quick so that you can see what these executions look like if you haven't seen it before. Step functions. Take the defaults here. And I want to say, like, we have a favorite saying about step functions. Think of it as int main for your, I need to look at that for a second. Okay, need to configure my credentials here. And then did that, all right. SAM deploy guided. Think of it as your main function for your serverless application, right? It's the one that is going off and calling subcomponents and managing the interactions in between them. Okay, here we go. See, so when you actually do the right thing and activate your AWS account, then it just deploys the same as you always have. And then from here, we have the ability to execute step functions from right here inside AWS, right here inside Visual Studio Code, sorry. Oh, I'm deploying to US East 1. That might not work. Give me a second. This happened to me the other day. Never tempt the demo people, you know?
No, that's how it works. Never. Yeah, live. This is how live goes.
Always. And that's why I said we aren't going to build live. I'll talk while this
But we
deploys,
do.
I'll talk about the use case. Yeah, right. But we do it anyway.
Yeah.
For the use case, Eric, I need you to like expand your imagination here for a second. Imagine if you can do it. You can do it.
Okay,
Come with
I'm
me.
trying.
Imagine if your job involved contacting or creating content from members of various online communities like Twitch or maybe Stack Overflow or Twitter or other areas. And let's say that you created content for them, and then that would be awesome, right?
Yeah, I can imagine that.
That wouldn't be enough. Eventually somebody would come along and say, yeah, but so what? Can you show me some metrics? And you'd be like, oh, yeah, I mean, I can, but I got to pull them
from many different places.
Many different places, right? And they're different everywhere. You know,
YouTube,
like you don't get
Twitch,
them the same way from
Twitter.
Twitch that you get them from Stack Overflow or from Twitter or whatever you have, Periscope. So what you could do once a night on a schedule, which is itself a type of event.
That's right.
You could begin some sort of business process to go out and gather those analytics from different places. But because you don't want it to be fragile, you could create a smaller nested business process to get your Twitch analytics based on information you specify. And a separate process to get your Twitter analytics based on a process you specify, right? Sounds pretty good, doesn't it? Can you visualize?
I can imagine. Yeah, I can envision that. In fact, if you build it, I would probably pay you good money for that.
I know it might not really seem real world. Yeah, we're sort of like meta talking about our own jobs right now. I know y'all all picked up on that, but yeah. So this is like a very real thing, and that's what we call nested workflows. What we were talking about with the invocations before. So what we're pushing up to the repo for you to look at later today is one big standard workflow that runs on a schedule nightly. It runs once a day on the daily rate. And it starts that workflow and calls out in parallel to the individual services. And each of those are their own workflows because you'll have different API calls, you'll have different ways of gathering and munging that data. But eventually you want to put it all back into the same database. And we use a DynamoDB service integration inside those workflows to put that information directly into a DynamoDB table. And then when those complete, we use the SNS service integration to publish a message to a topic. And that way we know that it ran with success, or we can handle the failures and publish the failures independently. But it's sort of a starting point for what's a pretty common pattern now, which is have a standard workflow. That's the long running ones that we talked about, calling out to component express workflows. Express workflows have a lot greater concurrency. They're a lot faster, but they're limited to 5 minutes. So they have to complete their execution pretty quickly. For an API call, that's enough, because when you think about the retries that are built in, maybe you do a 30-second timeout the first time, and then you do a minute back off with 2 retries. And then that works out to be like right at 4 minutes and 30 seconds, right? So that 5 minutes, even with those 3 retries, is enough for you to rate limit, even if you get rate limited, to go back out and try again. So that's that plus the inclusion of those 2 service integrations gives you a really solid pattern for going forward and expanding it to your own requirements. It also gives you, multiple state machines that are working together. So we're going to push that up right after this episode, and you'll have access to that code. For now, I just wanted to reload this, and we'll see that when we go to the right region, we now have this stock trading state machine in here, right? And we can start this execution directly from within Visual Studio Code. We don't need to provide it any info, so we'll give it an empty object. And ta-da, we'll cut back over to our console here and reload in the right region. And it looks like our stock trading state machine has run once. Looks just like what we visualized in Visual Studio for Code. It looks like based on our input, it was 60, so we're going to sell it because we want to make money. But if you look at the code, it's over under on 50, whether you buy or sell. So we sold it. We wrote into DynamoDB, get the timestamp of it. Ta-da, right? So this, again, if we go look at the DynamoDB tables, also created in SAM. You've seen all this. Beautiful stuff, right? So this state machine doesn't have any Lambda functions, or it does, sorry. The state machine doesn't use any Lambda functions to write to the DynamoDB table. It just puts them directly in via the service integration.
So that's an example of a direct integration, right? And we you got somebody calling you out on Twitter saying, "Are you going to be doing direct integrations?" And that's an example. And there's a ton of services that Step Functions can directly integrate with. And the nice thing about this is, if we can go back to the SAM template for a sec, you could build those in SAM. And so the idea here is your entire infrastructure is code, and it's done in SAM, right. And you have the ability to now add a state machine and reference those functions or those integrations.
That's right.
Call me out if I'm wrong. So,
no, you're absolutely right. Let me, I will show you an example of what one of those looks like, but you'll also have it in the code. But before we wrap this episode up, I wanted it to be in there. Store analytics, So this is a single state that I'm going to have to find a file somewhere. Give me a new file that looks like this. And this is Amazon states language. That's one state. And you just have there's a DynamoDB put item ARN that we pass in using that string replacement, the DynamoDB table, and you just give it the shape of your item and where that data is. And this is the context object here. I do a whole episode on JSON path in the links that we gave you to explain where that's coming from. This is a constant. It just writes that information into the table for you without you having to invoke a Lambda function. So I think it's pretty cool stuff. One of my favorite services, tremendously powerful.
One of the mantras that we talk about a lot of time is less code, less code, less code, less code. Yeah. And this is doing it. So how much DynamoDB doesn't take a lot of code to write to it, but it takes code. In JavaScript, I'm going to set the table. I'm going to do a promise. I'm going to check it. There's some things. So could I, in this, Rob, if it didn't write, can I put error handling right into the step function?
That's right. You absolutely can. You inside this resource here, you would insert what's called a retryer block. It won't let me do it because it's not. In fact, let me show you. Create a new state machine. I think we can do this in less than a minute.
Oh yeah, we can run over a little bit if we need to.
Do it.
Yeah.
Hello world. And so after this pass state, I'm going to show you another example, like an SNS task state. And any task state can have retriers and catchers. All right. Okay. So here we would put retry, and you define this retrier. So you catch, it's like a switch statement or a case statement. You catch different errors, and based on the first one that matches, it will apply that retry logic that you've done. So in this case, it will wait for 1 second, then do an exponential back off by a factor of 2. So 1, 2, 4. For a maximum number of attempts of 2. This is a maximum number of retry attempts, which means it will attempt the task 3 times, right? But so like you were pointing out, yeah, you don't have to do all that import, promise, etc. setup, but also if there's a vulnerability in one of those, you're not vulnerable to it in one of those dependencies that you bring in to do it. And people use a lot of libraries to munge inserts into DynamoDB or other things. But when you use a service integration, it's declarative, which means that underneath the hood, if there's a vulnerability to one of the libraries, right, it gets updated automatically. And that's even if you're in the middle of a year-long execution, right?
Right.
So even if you started this execution at a point in time in which something was vulnerable and it came up and got patched, you're protected mid-execution. So because it's just that declarative transformation. So extremely powerful stuff to cut that boilerplate code out.
Well, and here's a reality too. Biggest vulnerability that I've ever run into is my code. I mean, I hate to admit that, but that's the truth. And so when using something like a declarative language here to just say simply run this and not worry about me messing up on, did I catch that promise right? Did I catch that error right? It adds a lot of strength and really durability into applications that we don't have to continue to rewrite, right?
Yeah.
So
yeah, I agree with you. My code is absolutely the worst code I've ever read. One reason I got so much, I get things right the first time now. And it's not because I got any smarter, because I'm definitely moving the opposite direction on that. It's because the things that I write almost never go over 100 lines of code altogether anymore. And I got it, like the very opinionated statement, but I'm going to say it anyway. Stop handling errors in your AWS Lambda functions.
Yeah.
Stop doing retries, stop doing backoffs. If you get an error, return the error and eject, right? Just get out, which means that you can limit your function to just the happy path, right? Not just your function, but your tests to just the happy path. And then anything that fails, your function should essentially just return the failure. And you handle that back out in a declarative environment where you have a lot more choices and a lot more options of where you can send that simply. You want to put it into a dead letter queue, SQS service integration. Want to send it to an SNS topic, SNS integration.
Lambda.
Put it onto Amazon Event Bridge. Got to use the Lambda function for now. But you can still, like, you have the choice to put it out wherever you need to put it instead of handling it inside a domain function, which is not the right place to do those generic tasks.
I'm going to correct you. With Lambda destinations, I can kick it right out to an event bridge. So if I error with Lambda destinations, I can kick it straight to event bridge or another Lambda or an SQS or something like that. We could debate this in front of everybody, but I'm pretty sure that's the case. So
I'm going to be honest with you. Yes, what you said is a factual statement. I would not do that in workflow. I would suggest that that is a suboptimal pattern or even an anti-pattern inside a workflow because of the tight coupling. Now, it's there for a reason, right? You don't only invoke Lambda functions from step functions workflows.
Right.
At certain points, you may optimize away from something. You may decide that for business reasons, these things belong together in code. That we wanted to give you that ability. There are times when destinations is the right answer, and that's why it's there. When I'm giving you this opinionated statement of always eject the error, that's for the getting started case. When you get past that, and if you need to move off, which most applications won't, then you will absolutely know why at that point.
Yeah. Well, and that's one of the ways, and so I differentiate here a little bit. I think I like to eject into event bridge or into a queue. It doesn't mean necessarily I'm going to handle that error, but I'm going to know about that error, and I'm if I'm ejecting back to the client, obviously that way as well. But so, well, we are a little bit over, and you can watch Rob and I debate things all the time. Any show we're in together, so we have a lot of fun. We are twins. Some people may have not realized it was Rob speaking and not me, but I have this, the beautiful goatee and no thumbs. So there's the throw off. But we will be back next week. In fact, I'm going to go to my ending credits here so you can see a couple things going on. Number one, we got the template repo here. And if you're seeing that slipped out link, that forwards to a repo. This is the URL shortener that we talk about a lot. That is it's serverless URL shortener. Rob's is on Rob Sutter TV. Mine is on slipped out link. So that's the repo for this, and that'll also point you to the shows. We link the shows that tie into the repo. Next week we are going to be talking about using Amazon Elastic File System with SAM. If you didn't catch the fact that we released EFS for Lambda this week, actually just within the last day or so. So Mr. James Bezic is going to be joining me next week to talk about that. And then if you need more serverless, the one and only Rob Sutter is going to be back in about 24 minutes on his own channel. Twitch TV Rob Sutter. So he'll be talking. Rob, tell us a little. You're going to be talking about serverless analytics with Amazon Athena. You want to give a little recap before we head out? Okay. What?
Directly against in Amazon Athena. I'm going to show you how to use that and how to pull that stuff into QuickSight, all without ever standing up a database server. So that's
crazy.
23 minutes.
Crazy. All right. Well, I'll be there too. I'll be moderating, throwing in snarky comments. That's what I do. And thanks for joining us for Sessions with Sam. We'll see you next week. Have a great one.